Hello. Good afternoon. All right, we're catching you all at the end of a long day, but hopefully this is going to be an exciting session. I know, I think it will be.
I think it'll be.
I think it will be.
It'll be fun stuff.
I think it will be.
You'll see stuff that it's hard to do in most other platforms. So we'll see.
Yeah, and we're going to do a live demo. Fingers crossed. It's going to be amazing, though. So we're really excited. First of all, I think the obligatory, a lot of things here are forward-looking and could be subject to change, especially if we're talking about roadmap items. But anyways, just to kind of start us off, really excited to be here today. I'm Michelle, joined by TD. We're going to be talking about how you can leverage Unity Catalog to actually extend a governance across multiple engines and tools in your ecosystem. And so we're really excited about that today. First, I'll quickly introduce a little bit more about myself. I'm Michelle. I am a product manager here at Databricks. I work on our open Lakehouse offerings. Please talk to me about Unity Catalog interoperability, open table formats, and also where to find the best burritos in the Mission neighborhood.
All right. And I am an engineer at Databricks. I have been working in the Spark ecosystem for the last almost 15 years. RDDs, Spark streaming, data frames, Delta, now Unity Catalog, a whole bunch of stuff. Happy to talk about any of them. And best pizzas in Connecticut. Anybody here from Connecticut? Yeah.
I've heard of New Haven Pizza, though.
There you go.
I've heard of it. I've heard of New Haven Pizza.
Talk to me. Talk to me about New Haven Pizza. Okay, good. Okay, so what we're going to do today is we're going to talk about why UC is the right catalog for you. To understand that, we really dive deep into what makes a great Lakehouse catalog. We're going to focus about what open APIs that UC supports, and we're going to go into demos of showing how you can use UC with not just Databricks, but other stuff as well. And then what's next? What can you do to participate and take advantage of all these things that we're building? Okay, let's start with the first most important question. What makes a great Lakehouse catalog? And by specifically, I'm referring to Lakehouse catalog because Lakehouse is the new thing, and Lakehouse encompasses, that is the future. And so what a catalog that was built in the past, a decade ago or 2 decades ago, is insufficient, as I'm going to show, to handle the needs of a Lakehouse that is for the next 10, 15, 20 years. So to understand that deeply, we need to first understand what do modern data plus AI workloads look like. This has been changing over time, especially in this Gen AI era. Things don't look the same anymore. To really understand this, let's walk through, let's imagine all of us that 2 of us here have a shoe company together, and what we can do to deal with all the data we need to handle for our shoe company. By the way, Michelle, I named our shoe company, if you hadn't noticed. It's Michelle and TD's Awesome Shoes.
That's amazing.
Better
Where's
than
the
Nike.
AI-generated art for our shoe company?
Yes.
Oh, it's coming. Yeah.
Yes, yeah. Okay, so let's start designing at a high-level architecture. What we need to do for handling data of this company? To start with, you have customers. We have customers, and we have like transaction data coming in. We need to track them. We need to ETL them. So first, we start by hiring a data engineer who takes all this data coming from different sources, preps the data, builds a standard medallion architecture, bronze, silver, gold pipeline, takes the structured data, unstructured data, puts it into structured data, creates these tables, orders, customers, et cetera, et cetera. Then we hire a data scientist. Like, we need to make sense of this data, like get insights out of it. So data scientist comes in and starts building reports on these structured tables, orders, customers, et cetera. Then we have actually revenue. Maybe we'll see some profit. So we need a financial analyst to see, okay, where are we going? Are we doing good? Are we doing bad? So the financial analyst says, okay, I know where we are doing now, but is this growing? Is this getting better? So I need some forecasting trends. So that means that in order to do projections, I need to hire, or the data scientist can do ML engineering and build AI models to do projections, both demand projection, financial projections, et cetera. But then, that as a result of that, like the number of reports that are coming out is like growing. Like now there are hundreds of reports, like so many insights, et cetera. I don't know, I'm the CEO, CFO maybe, together we just don't know what to do about where to get the answers that we want. It's just too complicated, so I need some simpler answers. On the other hand, we have customers who are demanding questions like, where is my shoe order? How long is it going to take? Customers about their transactions. And then there are warehouse managers. So we are storing shoes in the warehouse. They want how many orders. They want projections of the demand as well, like how many orders shoes I need to stock, etc. So all of these questions now in today's world, we are building AI agents to answer these questions. We will take the data present in all our reports, all our models, combine them together and provide simple answers. That is today's pipeline, what it's starting to look like. Now let's start getting deeper. How do we build this? Today, to build this, we have to put together various different things. There's on the left-hand side for the ETL pipeline, the traditional catalog has been Hive Metastore, storing data on storage systems, cloud storage, etc., using whatever processing engine, Spark, Flink, Trino. Today, DuckDB is hot. Whatever, we want to use whatever tools we want to process the data, get insights out of it, produce reports and stuff. And then the ML stuff is like more new. There's things to track the ML flow models and stuff. There are things like ML flow, weights and balances, etc., to track these models, and a random ad hoc mix of deployment tools to deployment these models and stuff. So it's a whole mix of tools that we need to use. But an insight here is that we have two different worlds here. There's a table catalog that is only for tables, and there are model catalogs and registries that are only for models, and two different worlds. Furthermore, we have to deal with multiple formats. Data is coming from all different sources, some JSON, some Avro, some even CSV, text. We need to accommodate everything under the sun within the table world. So we need a catalog that can both handle classic formats as well as newer formats like Delta Lake and Iceberg. While Hive Metastore kind of supports everything, but not really, because it doesn't give the transactional guarantees that today's modern formats like Delta and Iceberg actually need. We need a catalog that can be enhanced further to accommodate these newer format requirements and give the better guarantees. The other problem that I need to deal with is that not everybody in our company really should have access to all the data. For example, data engineers understand that they need to really structure the data, they need access to all the tables, etc., to manage them and stuff. But the data engineer doesn't need to understand all the reports and models and agents and stuff. Their job is very well defined. Similarly, data scientists need to access the models because he's building the models, but doesn't need to have full access to all the agents and stuff. Similarly, customers, when they are querying using the agent, they need to have access only their own data, their own customer data, their address they can modify, their transactions they can ask how long it's going to take for the shoe to arrive. Warehouse managers, on the other hand, needs to access all the order data to understand what the demands are, etc., but not customer data. That is PII. Data warehouse managers should have no access to that. But on the other hand, they're all going through the AI agent. So the AI agent needs to have access to all of the data, but selectively, depending on who is asking the query, give access or use the data from the tables or models based on who is asking the query. So kind of like masquerade the user and use the user's permission. So this is the whole problem of security, access control, and governance. Then there is now even if we figure that out, there's a major practical challenge that in order to make sure that when you're running queries, it can access your cloud storage, you have permanently configured credentials now. Your S3 access key secret key, you give Spark that here is my key, it's permanently set, and every query goes to it, independent of which user should have access to what. It is permanently, so you cannot revoke it very easily if one of our employee actually leaves the company. That's not great. So this is the practical challenges of this data system. So data and AI assets are in two different silos, different trackers. Governance is hard across them. Governance fragmented, increases administrative costs, and then modern table formats are not truly supported by traditional catalogs and stuff. So our goal in building Unity Catalog has been to give our end users the flexibility to use all the assets, data, AI, with any tool they want without sacrificing security and governance. That's what we went on to build. Unity Catalog, a multi-format, multi-modal, and a unified catalog. And we're going to walk through what it actually means and what you can do with it. So from disjoint silos, we have a unified single catalog, which is a source of truth for all your type of data assets, all the critical properties of your assets. And all your accesses from users, from engines, go through the Unity Catalog, so that Unity Catalog can govern that who should have access to what, and deny, allow, deny accordingly. And then Unity Catalog, because it knows everything, it is a trusted entity. It has access to all the storage that it can govern on where all this data is stored. And so it can selectively give, according to the who's asking the query, give temporary credentials to the engine, so the engine can use temporary credentials to answer the query. And so since it's temporary, if the user goes away or the employee goes away or the employee's role changes, so access changes, Unity Catalog can govern and deny giving access to credentials, those temporary credentials. You have centralized control. And to complete the story, it's a new catalog. It gives better support for newer formats like Delta Lake and Iceberg. For example, for Iceberg, we support the Iceberg REST Catalog. For Delta Lake, we are building the necessary catalog-based commit APIs that Delta needs for doing catalog-based coordination, while also having support for classic formats and stuff. So you have the freedom to use whatever format you want, getting the best of all the formats when using Unity Catalog to coordinate among them. So your data and assets are unified, your governance is unified, and you can choose whatever modern table formats with the right guarantees. So that's the full view. There are lots of things in Unity Catalog that Unity Catalog in the Databricks platform provides. Lineage, discovery, a lot of things. But there's a ton we can talk about, but this talk is focused on only the open APIs and how you can use the open APIs to access the data assets from outside Databricks. With this, I'm going to hand it over to Michelle for more going into details of what you can do.
Amazing. All right, thank you, TD. So I'm going to quickly walk through basically the core components of Unity Catalog, open APIs, and what assets it gives you access to. And then I'm going to jump into a demo. So as TD was saying, our goal and the vision is that Unity Catalog enables any engine or platform to access your data and AI assets with unified governance. And so here's how it does that. The first is that Unity Catalog exposes open APIs. So there's the Unity REST APIs. You all may remember we open sourced Unity Catalog last year. Happy 1-year birthday to Unity Catalog. And so those are the Unity REST APIs. There's also the Iceberg REST Catalog APIs. Unity Catalog has a full implementation of the spec. And then, of course, also Delta sharing, another open protocol for secure sharing with other organizations, for example, like cross-domain sharing, where it might be a user or an account that doesn't even have an identity within the Databricks platform. And these APIs, open interfaces, they give you access to all types of tabular data, full read and write access, external tables, managed tables, views. We can actually demo all of those today, and tables of all table format types. So Iceberg, Delta, Parquet, and all the classic formats that TD was just mentioning. All of those can be read and written to through all three, actually, of these APIs. Well, Delta sharing is read-only. That's because it's for secure sharing. You don't want another third-party vendor writing to your data sometimes. And so I'm going to double-click really quickly into this because I know that this is something that can potentially be confusing. Okay, there's external tables, there's managed tables, and now you're talking about federation. So now Unity Catalog can actually go read and access assets that are held in a foreign catalog. Say you're using like another catalog, maybe an external HMS, for example. And so there's actually three sort of core table types in Unity Catalog. There's foreign, which is the federated tables, where it's another catalog that you see as federating to. There's external tables, where essentially the key distinction here is that this is like file system managed tables, where you get full access, of course, from Databricks and stuff like that, but a lot of these other things like performance optimizations are manual. And then finally, there's managed tables. And so the key distinction here is that this is a sort of a catalog managed table. So as TD was mentioning, modern table formats, in order to get some of those really fantastic like transactional guarantees, security, governance, observability, they need to sort of participate in and become much more catalog oriented. And so Delta Lake and Iceberg, Unity Catalog supports both of those as managed tables, where we actually go in and provide automated performance optimizations and better observability and auditing and storage cost reductions by nature of having that visibility. And we also provide, for example, something that's in preview today actually is multi-statement transactions and multi-table transactions. Okay, so that's a little bit more about that. I realized I just kind of talked through this slide. I guess I'll leave it up because I noticed that some folks are maybe wanting to take a quick photo. So I'll double click really into some of the benefits of managed tables that I just mentioned, where we have this AI-powered intelligence called predictive optimization. So what this is doing is Databricks bringing data intelligence to optimizing your table. So you get better performance so we can optimize your storage costs. I've known multiple customers that are saving, just by virtue of simply turning on predictive optimization, saving over $1 million a year in storage savings. And of course, also managed tables are becoming the standard on Databricks, where 65% of UC workloads are using managed tables. All right, so that's a little bit more on managed tables. And of course, as I mentioned, they're all accessible via the open APIs we just mentioned. The other thing that's really cool is, as TD was saying, Unity Catalog enables you to govern all your data and AI assets. So that means unstructured data that can be in volume, so like images, audio,
texts,
PDFs. I mean, that's really common, right? Is you want your agents to be able to like talk to PDFs essentially. And so Unity Catalog also governs those and also again provides open access and credential vetting. So I'll actually go demo that too. And then finally, you can also build Gen AI workloads using functions and models, again, governed in Unity Catalog alongside maybe that unstructured data, maybe the tabular data that you had that was used to actually go develop those models. Those are all governed end to end. And then now, of course, we're bringing in agents, as you heard this morning. And again, governance also extends all the way through to agents. And so I'm really excited now because I'm going to go into a live demo. I'm a little bit nervous. So here's what I'm going to demo for you all. I'm going to demo 4 different tools accessing managed tables, materialized views built by declarative pipelines with Lakeflow, and going to demo leveraging a multimodal query engine with Unity Catalog volumes and credential vetting. So it's a packed demo. I will try to walk through it and explain what's happening because you're going to see, of course, I'm going to be jumping through multiple tools. And so I'm really excited. So let's get started. And I'm going to put down this clicker. Wish me luck.
All the best.
Thank you. Thank you.
May the demo gods bless us.
Thank you. All right, so here, let's start off simple. So TD, right, we run a shoe company. And so maybe let's take a look here. So I have here in the Catalog Explorer, here I'm in Databricks. And so I want to take a quick look at, of course, this is where I can view all the data and AI assets in my organization. And here I have a table. It's a managed table in the Delta format, so you can kind of see that here. I can zoom in actually a little bit.
Yes, I think that would be useful.
Oh wait, why did that? Okay, well, here, let me get rid of this. There, now you can see everything in one screen. It's a managed table. Managed tables, as I mentioned, they provide a lot of those amazing predictive optimizations and data layout optimizations on top of it.
Zoom
and
more.
Furthermore,
Moshiko is saying zoom more.
Moshiko is saying zoom more. Yeah, but if I zoom more, then here. Is this good? How about this? Is this good for folks?
Thank
Better?
you.
Better? Okay. Awesome. And then now let's take a look at some of the sample data. So here's our customers. I guess we don't have very many customers. We have about 6 customers, but we're a global shoe company.
It's been 1 hour since we started the company. It's okay. We'll get there.
We'll get there. And so, well, actually, maybe let's go change that. So as I said, I showed you, this is a managed table, and you can see this is actually in production. And now I'm going to hop over to, let's see, where is the window that has Spark? Okay, here, let's start off with something classic. Let's open up Spark. I'm going to delete this token after, but basically what you see here is I have Spark configured with Unity Catalog using the UC.
Can you zoom that as well?
Yes, I can. Yes, I can. This is really small. Yeah. So I've configured it with Unity Catalog. So all this documentation can be found online for how to configure. And I'm just going to start up Spark really quickly.
Yep.
Maybe I should make the window, because it's like right next to the captions, actually. I want you all to be able to see the stuff that's happening. Okay, is that a little bit better? At least you're able to see now. Okay, cool. Amazing. And so, while I've connected it to Unity Catalog, so let's actually go, let's just do a quick test. Let's go hello world, make sure I'm able to access the same table that we were just looking at, our customers table. Takes a little bit of time.
So what's happening in behind the scenes is actually this open source Spark, pure Spark 4.0 released a couple of weeks back, that is actually configured to talk to the Databricks UC via your PAT token, your personal access token, or OAuth, whatever you pick, and pointing to a particular catalog in Unity Catalog. And so when the query is running, when the query ran, it actually talked to Databricks UC, talked to the catalog, resolved what brickbytes.sales or dim cluster is. It figured out where is the path to the Delta table. It actually got credentials, those temporary credentials I was talking about. It actually, UC gave back the temporary credentials in some S3 path somewhere that I don't know where it is. I didn't configure that. I don't need to configure that. UC gave back the credentials, and my Spark application was able to read the table. I didn't have to configure anything. Everything happened on the fly. All I need to configure was pointing to my UC Databricks workspace. That's it.
Yep, which is incredible, because I don't want to have to go talk to IT again to get access to our S3 bucket and ask for a bunch of permissions. And so actually now I can also write to this. Like I said, we didn't have very many customers, but it looks like we just got a new customer, Janice.
Oh, nice.
Yeah, so I'll go insert this here, and then actually let's go hop back over to, I have so many windows open. Let's go hop back over, give this a quick refresh, and then here you can see that we now have, thank you.
Somebody's happy.
Someone's happy. Yeah, so now Janice is one of our customers. We're like growing our business.
16.66% growth.
That's actually massive growth over the past minute. And so, yeah, so as TD was saying, I mean, what's really exciting here is that you're able to, this is just Spark that I have locally with vended credentials. I was able to read and write to this managed table. Okay, but it doesn't stop there. All right, so I also can access and read and write to Unity Catalog managed tables from Starburst. So some of you all may be familiar with this. I'm going to go jump in. So here I'll just quickly flash on screen. So I already have, this is something that we've been working with our friends, actually they're in the room, our friends over at Starburst, the folks who are also behind the popular query engine Trino. And so I've already got here Starburst. It's configured with my same catalog, the brickbytes catalog that we were just looking at in Unity Catalog. And so you can see here it's that same workspace URL that we were just looking at, and I've configured it. Super easy. Now let's hop back over here. Again, we'll do another quick, let me zoom in. We'll do another quick little hello world. And amazing, you can see I can read from this table with
How many
Starburst.
customers? Is it 7?
7 rows.
Okay.
7 rows. Well, it's working.
It's getting, the bottom is getting cut off.
Oh,
so,
yeah. Here, I'll scroll down. But
7
it says
rows.
7 rows.
Okay, 7
it gives me
rows,
a nice
yes.
little summary.
Oh, yes.
Yeah. Amazing. Here, I'll close this. And so now let's actually go, and maybe, it looks like maybe we have another customer, actually. Another friend. Oh, I meant to do this. And so now let's add Gunther. So another customer just came in, and now I'm going to go run this from Starburst Trino. And again, this is again going through the same process. Wow, that was really fast. Let's hop back over here, and I'll give this a quick refresh. And then you should see that these changes are automatically updated here in Unity Catalog. Here's Gunther. And again,
14.2857% growth.
I know. We're getting so many customers by the minute. And so a little bit about this, right? This is, again, this is not a separate catalog. All these changes are here in Unity Catalog. This is just like any other Unity Catalog managed table. And you can see here that I was able to access it not just from Databricks, but also from Spark that I had running locally, and also from Starburst with Trino.
Actually, I want to double down on that. I think I think it's worth appreciating the fact that I think there are other platforms out there where they have open access via 2 different versions of their catalog. There's like catalog on which you can do workloads in the open source, but only internal systems can read from it. And then there's another catalog that internal systems can read right from it, but only external systems can only read from it.
Yeah, and sometimes those reads are stale because they're syncing metadata between them.
Because until you sync the catalogs together, the stale is coming from one side or the other.
But we're not going to name names, don't worry.
Yeah, none of that. This is one single source of truth, no matter whether inside or outside.
Huge, huge.
It's huge.
Very huge. I mean, we think it's cool. Obviously, we work on this stuff. All right, so doesn't stop there. I have more to show you. So now I'm going to hop on over. So sales have been going so well in our shoe company. So I have here, now we have to go project out inventory, right? So I actually have a materialized view here, which actually forecasts inventory. Are we going to run out of supplies? I mean, we have so many customers. We have both Janice and Gunther now. So we want to make sure that we're not going to run out of supplies. So we need to combine data from our sales and supply chain here in this materialized view that forecasts out current inventory below 10%. All right, so remember this. Here, actually, I have to go copy it because I don't remember how to type this out. Now, remember this. Now I'm going to hop back into another tool. Now I have DuckDB. So I've already configured it here this is DuckDB, and I've loaded the Iceberg extension. So what we just saw was we saw with Delta, right? But I said that Unity Catalog also has interoperability across formats and with multiple open APIs. And so I just showed you how to use Delta connectors with Unity Catalog's open APIs. And now I'm going to show you DuckDB, which is configured with Unity Catalog's Iceberg REST Catalog endpoint. Again, I said it has a full implementation in the spec. And we also not only enable you to access tables, Iceberg tables, we can also access materialized views and streaming tables, so tables that are produced by declarative pipelines of my Lakeflow. And so I'm going to come into here, and let me go copy paste in what I just copied from the catalog. I have my fingers crossed for this one. Oh my God, it worked.
Ooh.
Yay, okay.
Yay.
There's no surprises there, so this is actually, like I said, it's reading from materialized view that's produced by Lakeflow declarative pipelines, and you can actually access this table from DuckDB locally with the Iceberg extension through the Iceberg REST Catalog APIs. This is in preview today, Mashiko, before you ask. So, all right, now, the demo is still not over, you all, because I'm going to show you one more tool.
It's going to get cooler.
It's going to be really cool because there's going to be pictures here. So now I said that Unity Catalog not only governs across tables and formats and materialized views and all these amazing things with pipelines, I also said that Unity Catalog governs your unstructured data as well, right? And so I've been working on a marketing campaign for our shoe company.
Ooh, thank you.
Yes, I have, to really drive up the demand. And so I actually have a volume here with some marketing assets, and I also have some asset metadata here. So now we're going to get multimodal. And so I have Daft here. Let me zoom in, which is a multimodal query engine. I've already configured it to connect to Unity Catalog. And here I think I've already loaded the volume, and I think I've already loaded the volume. And I think I already actually read the table that contains references to images in that volume.
Actually, yeah, let's show that. Show what the table contains.
Yeah, so let me go show this really quickly. Oh.
Whoops.
All right, maybe I didn't actually run all of these. Let me run all of them. Let me just run this. Let me restart the kernel. Let's try this. Okay, we'll restart. But here, since the demo is actually going to go pretty fast, I think we should explain what's about to happen.
Yeah, so I think, I don't know if you're familiar with volumes or not. The idea of volumes is that here is a directory in the cloud object store, S3 or whatever, that can contain arbitrary stuff. It's not a table. It can contain arbitrary stuff. It can contain images, etc. You can define, you can even define tables inside it, or a directory of images, or a directory of audio inside. But that volume is something UC has credentials and can vend temporary credentials to others even to read the contents of that directory, of that volume. That's what we're doing here. So let's show the initial table, which has the
yeah, so this is the table,
yes,
which has a bunch of images. Well, it's actually metadata about images.
metadata about
This
images.
is metadata.
Exactly.
So this is the asset metadata table that we were just looking at in Unity Catalog. It contains a bunch of metadata about those images.
And we created the table in Databricks.
This is created in Databricks here. I can go show you all here. This is the asset metadata table here. And here's some of the sample data. You can see it's exactly the same. And now we're querying it from Daft, which is this multimodal query engine. And you can also see that there's
DBF
a pointer
is volumes.
here.
The right-hand side column is the volume.
You-
That is this. Those are the paths to the images inside the volume defined in Databricks.
Yes, these are the volumes. If I could scroll here, yeah, this is the volumes that are defined in BrickBytes marketing assets.
Yep.
And so now you've seen this asset metadata table. I've also loaded the volumes earlier here from brickbytes.marketing.assets. And then now I'm going to use the credentials. So again, Unity Catalog actually will then credentials. So notice how I never had to configure this to talk directly to S3 or give it any sort of access keys or roles or anything like that. This is all using Unity Catalog vendor credentials. And then now it's using those credentials to actually go fetch and decode those images. And then let me go show you what that looks like here. Oh, wait, did this? Oh, yeah, it worked. Yeah, OK, great. Yeah, so here's some of the, well, as you can see, they're actually not photos of shoes. I didn't have a bunch of photos of shoes on hand. But here is all of our marketing assets. And you can see I'm displaying some of the metadata. And alongside the volume that was a pointer here, we actually went and fetched those volumes and decoded it and rendered it here, all again powered by Unity Catalog with unified governance.
Amazing.
All right. Thank you so much. OK, now we're going to go back here. And again, I'll just quickly recap. What did we just see? We saw reading and writing to Unity Catalog managed tables from Spark. We saw reading and writing to the same managed table from Starburst. We read from materialized views with DuckDB, with the Iceberg REST Catalog APIs. And we read in multimodal data in tables and volumes from Daft. And so all of these things, again, Unity Catalog is able to provide open access and centralized governance across all of your data and AI assets. And as I mentioned earlier, Unity Catalog is open source. The momentum has been amazing. In Databricks, 70% of all customer workloads run on Unity Catalog. We recently pulled the download stats, over 500,000 monthly downloads for Unity Catalog OSS.
Yep.
100 contributors, and a growing, amazing ecosystem, as showed by many of our friends here in the room. And here's some of the growing integrations, as well as our amazing Delta sharing partnerships.
Which we didn't even talk about.
Which we
I mean,
didn't really.
There's so much to talk about, but we didn't even get to the sharing side.
I know. There's a lot here to talk about. We also didn't talk about federation and stuff like that as much, but happy to talk about that afterwards. And so, as I mentioned, you can use any format with Unity Catalog. You can use any tool. You can bring and govern all of your data and AI assets, and Unity Catalog can, again, be that single source of truth with full open access and interoperability with any tool, delivering on that vision and supporting those modern data and AI workloads that TD was talking about earlier. All right, so let's talk a little bit about what's next. I'll do a quick preview. Oh, if you want to take a picture, I guess I'll pause on this slide for a second. Yeah.
Yeah, if this is the, if you want to leave this talk with one takeaway, this is the takeaway. You have the full flexibility to choose anything that you want, Databricks or not Databricks, but if you use UC, you have the full governance and all the capabilities of UC with whatever tools you have picked. That is the one takeaway if you have to leave this room with one.
Amazing. All right, so let's talk about what's next.
Sorry, I think I stole this.
Oh, yeah, no worries. Yeah, so here's what's next. So here's some of the things that actually that's not what's next, this is what's now. This is all the things actually that are public preview, private preview, and GA today with respect to Unity Catalog interoperability. So UC open APIs, all those open interfaces, access to those different assets that I talked about, Iceberg support, managed deltas, reading MVs, materialized views, and streaming tables from external Delta or Iceberg clients. A lot of those things are in public or private preview today. And then on the Lakehouse Federation side, so this is Unity Catalog being able to govern your assets that are in other catalogs or other databases or platforms. We've been adding many other connectors and Catalog Federation as well, which is something where you're actually able to like directly query for Lakehouse formats from other catalogs. And some exciting things as well up ahead on the roadmap. So roadmap, multi-engine, fine-grained access control. And so this is something actually that if tomorrow you come to the keynote, you might see yours truly demo this. And then also on the roadmap is public preview for credential vending for volumes. This is something else as well that's coming in the next quarter. All right. We said a lot, TD.
You said a lot.
We said a lot.
Maybe you have questions?
Yeah, and if you take away anything, it's that Unity Catalog is truly open, interoperable, and provides all this amazing data intelligence features and external read-write access from any engine. It's amazing. All right, thank you so much.
Thank you so much, everyone.